There are whole planets people believe exist that don't, like J1407b, which was proven false years ago. This video is about habitable exoplanets. Everywhere you look, people claim NASA found Earth 2.0, or that some planet is more suited for life than Earth. Most focus on specific planets like Kepler 22b, Kepler 186f, Proxima Centauri b, the Trappist I system, and others. But what people often don't realize is that none of these planets are truly good candidates for life. They might be our best options right now, but that just means the rest are even worse. I'll explain planet by planet why these potentially habitable exoplanets likely aren't suitable for life. After that, I'll discuss a few planet candidates that might actually be good options. First up, Kepler 22b. Kepler 22b is in the habitable zone of its star, meaning temperatures could support liquid water. Beyond that, though, it has nothing in common with Earth and should have been dropped from the list of potential candidates a long time ago. For starters, we don't even know its exact mass, just that it's less than 9 times Earth's mass. We do know its radius is 2.3 times larger than Earth's, which suggests it's not a rocky planet. This probably means Kepler 22b doesn't have a solid surface and is more like Neptune. It could also be a water world with deep oceans, but even that doesn't guarantee habitability. Ultra-deep oceans likely aren't great for life since volcanic activity seems necessary for life to start, whether through hydrothermal vents or hot springs. If Kepler 22b is an ocean planet, the water pressure at such depths might make volcanic activity nearly impossible, making it an unlikely candidate for life. Next on the list is Kepler 186f. At first glance, Kepler 186f seems better than Kepler 22b. It has a mass comparable to Earth at 1.5 times our planet's mass, meaning it likely has solid ground. Of all the planets discussed here, Kepler 186f probably has the best chance of being habitable, but it's still not ideal. Its estimated equilibrium temperature is 120 degrees Fahrenheit, or 85 degrees Celsius, which is colder than Mars. In fact, it's closer to the temperatures we find between Mars and Jupiter. That temperature estimate comes from assuming the planet has no atmosphere, and while a greenhouse effect could warm it, it's still likely a very cold place. If you manage to get an atmosphere thick enough to make it warmer, there's a risk of creating a Venus-like atmosphere. So, Kepler 186f might be too cold, too fragile, or even a runaway greenhouse world. The planet exists between two extremes, and we don't know where it falls yet. Everything about Proxima b's environment seems to work against it. It orbits a red dwarf, which flares a lot, probably stripping away its atmosphere and any water. It's also likely tidally locked to its star. Add in the existence of Proxima Centauri c and the possibility of an asteroid belt between the two, and it's even worse. Proxima b might be constantly bombarded by asteroids. Temperatures on Proxima b can also spike due to the frequent flares from its star. All in all, it's hard to imagine a scenario where Proxima b is anything but an irradiated wasteland. We don't know for sure, though, because it doesn't transit its star, making it hard to study. But based on what we know, it seems very unlikely that Proxima b could support life. Trappist I is another interesting system with 7 Earth-sized planets, 3 of which are in the habitable zone. But like Proxima b, the Trappist I planets are subject to flares from their red dwarf star. Trappist I is calm compared to other red dwarfs because it's older, around 8 billion years, but that just means it was probably more active when the planets were forming. Over time, the star likely stripped away the atmospheres of the planets. We've already seen evidence of this. Trappist 1b, the innermost planet, likely has no atmosphere, making it similar to Mercury. Trappist 1c, d, and g also show signs of being airless, and there's still not enough data. If most of the planets are airless, it doesn't bode well for the rest of the system. Next, we have K2-18b, a planet about 8 times the mass of Earth. This mass alone means it's not Earth-like. For comparison, that's half the mass of Neptune, which makes habitability slim since it's probably an ice giant or a water world. Recently, the James Webb Space Telescope detected potential signs of life on K2-18b, specifically dimethyl sulfide. But this has been overhyped. Webb detected evidence for it, not a definitive detection. GJ667cc is another planet with a slight chance of being habitable. It has an estimated temperature of 39 degrees Fahrenheit without an atmosphere, making it slightly better than Kepler 186f. However, it has a mass 3.5 times greater than Earth, and it also orbits a red dwarf star, meaning it faces the same issues as Proxima b. Despite all these issues, there is one that stands out as a good candidate: QI 700d. It orbits a young red dwarf, which works in its favor because it's much brighter, allowing the planet to orbit further out, reducing the chance of losing its atmosphere or becoming tidally locked. It also receives a similar amount of energy from its star as Earth does from the Sun. TOI 700d is about 70% larger than Earth, meaning it's likely rocky and could hold onto an atmosphere. Its size and geological activity could help it build an atmosphere and possibly support life. While we don't know for sure, TOI 700d seems to be the most promising candidate for an Earth-like world. The second last one, we have Ross 128b, orbits a relatively quiet red dwarf star, which makes it stand out from the other red dwarf systems we've discussed. Located just 11 light-years away, it's one of the closest exoplanets we've found that might be capable of supporting life. Unlike many red dwarf stars, Ross 128 is unusually calm, meaning the planet may not be subjected to the same levels of harmful radiation as planets around more active stars like Proxima Centauri. Ross 128b is close to its star, completing an orbit in just 9.9 days. But because the star is much cooler and dimmer than our Sun, the planet still sits in the habitable zone, where liquid water could exist. However, the planet is likely tidally locked, meaning one side always faces the star while the other remains in eternal darkness. This creates extreme temperature differences, which could make the planet less favorable for life unless there's a way for heat to be distributed across the planet, such as strong atmospheric winds. We don't know much about Ross 128b's atmosphere yet, but its proximity to Earth makes it a good candidate for future studies. If it has an atmosphere and liquid water, it could be one of the best places to search for life outside our solar system. And the final one, LHS 1140b, is another planet often mentioned as potentially habitable. It's a super-Earth, about 6.6 times the mass of our planet, and orbits in the habitable zone of a red dwarf star. Its size means it likely has a thick atmosphere, and given its location in the habitable zone, temperatures could support liquid water. However, there are still some major challenges when it comes to LHS potential for life. The planet's star is a red dwarf, which, like other red dwarfs, tends to be quite active. This means it might blast the planet with harmful radiation, which could strip away its atmosphere over time or make life difficult on the surface. Despite these challenges, remains one of the better candidates because of its size and the fact that its star is older and less volatile compared to younger red dwarfs. Scientists have already detected a thick atmosphere around LHS 1140b, but we don't know its exact composition yet. If the planet has a strong magnetic field to protect its atmosphere and water, life could potentially develop. However, its status as a super-Earth also makes it a challenging place for complex life to evolve, as gravity would be much stronger than on Earth. But always keep in mind, just because a planet sits in the habitable zone doesn't mean it's actually habitable. Many of these planets could be as harsh and unlivable as Mercury, Venus, or Mars. Finding a true Earth-like planet is a rare event. However, we believe that day will come eventually. Thanks for watching. If you enjoyed the video, don't forget to hit the subscribe button, and share your thoughts in the comments. Have a great day.